Okay, couple quick things. Zoom changed its preferences, so you cannot record on Zoom without a paid subscription. I do not have paid subscription money. 2, we will be trying it in this way. We are going to record it. We're going to screen record the different pieces, and then we'll compile it together. Now, I'm not sure it'll still record when I get out of this app, so we're gonna try it. And good evening. My name is Naomi, Miss Jones, Miss Naomi in class. I am a 6th grade math, science, and health teacher, and I'm taking 504 with Professor Ken. So today we're going to be doing 6th grade math. We're going to try and find the area of different shaded rectangles through decomposing some polygons, some irregular and regular polygons. That basically sounds like a bunch of jargon. So what that looks like is going to sort of help us go step by step. First and foremost, let's go over the common standards, and then let's go over how this lesson is going to apply to constructivism. So as we know, constructivism requires us as teachers to allow multiple points of entry at the students, starting with the student's prior knowledge and prior experience. Now, if this is experience-based, that means it's also going to work with a lot of hands-on, minds-on material, meaning it's also going to function as a sort of addition, or not necessarily assimilation, more adaptation of some conceptions that the students already have. That means there's going to be a lot of virtual manipulatives, physical manipulatives, and real-world application. That real-world application and virtual manipulatives is the 2 formats that we're going to work in today. So I hope you enjoy. Common Core Standards for 6th grade has us looking at students in grade 6 will also build on their work with area in elementary school by reasoning about relationships among shapes to determine area, surface area, and volume. They find areas of right triangles, other triangles, and special quadrilaterals by decomposing the shapes, rearranging or removing pieces, and relating the shapes to rectangles. I'm not going to sit here and read it all to you, but the parts that we're going to focus on today are highlighted. Build on their work with area, focusing in on relating the shapes to rectangles. So our focus is decomposition of irregular shapes or different shapes into rectangles. By the end of this lesson, our learning target is I can find the area of a polygon by using multiplication and subtraction. So I want to get us started with a quick prior knowledge understanding. What shapes do you see or do you encounter in your daily life? Now, constructivist teaching tells us we need to focus on multiple entries from students' prior knowledge, dealing mostly with what they encounter, especially misconceptions, and stem the lesson from there. What that basically means is we start off with almost like an inquiry-based question, and we move forward into building off of that, trying to find a similar starting point so that all the students can start. So this is our starting point today. What shapes do you see that you encounter in your daily life? From here, we would move forward into what shape is a house or a stop sign? What about a basketball court or a pool? In my classroom, they are very much addicted to sports in different forms. So using some of those regular encounters of their daily life, whether that's a football court, a soccer field, a baseball field, or a basketball court, or even a pool. Understanding what the shapes look like is really, really helpful. Then we'll use pattern blocks or digital or physical pattern block manipulatives to demonstrate the different shapes that we encounter every day. What that looks like is something like this. We are looking at trying to create some things that we already encounter. So if I have a swimming pool, I could put my pattern blocks out from my swimming pool. I know that my swimming pool is a little bit of an irregular shape. So there it comes to a strange point. So I'm going to try and make that point. So the different shapes that I would have them recognize is square, triangle, rhombus or parallelogram, and trapezoid. Knowing this, now they can decompose this shape into shapes that they already understand. From here, we would move, this was also from here, this was Didax. So some virtual manipulatives to figure that one out. We used pattern blocks. Then from here, we move back into our lesson. This was either something that I give to them. I have a differentiated integrated classroom, so I give them it on paper, have them draw it out, but I also bring out the manipulatives for them to use. From here, we would start applying some of our classroom learned knowledge. So in a partial product / area model, what two things are we multiplying? Here, of course, they would answer back. They would be able to answer me back and say, okay, we use length times width and the shape. And I would ask them, I would further the question walking around the classroom, ask them what shape it would be, and they would tell me back, hopefully, rectangle. Either drawing it out, showing me that an area model partial product kind of looks like this, and knowing that the inner pieces all give us, or the outside, right? So if this was 20 and 3 and this was 10 and 5, the outside would give us our length times our width. This was 23 times 15. That would give us our length times our width. Now, moving forward from here, I would have them get into small groups. Again, working with that constructivist model, trying to help them build on their knowledge. So we're going step by step here. If we are getting the product of those two things, then how do we find the area of a rectangle? So we know that that in a partial product area model, what we're looking at is the length times the width. So that basically lets me know that when I'm looking at a rectangle, the area of a rectangle, I would apply my knowledge of length times width. What about a square? So this is one of those furthering questions that I have students try just to see where their knowledge is before our mini lesson. Even rectangle, might I add. We have how many squares, right? So we know that a square can fit inside a rectangle. So if rectangle's area is length times width, then we need to know that a square's area would be the same. Length times width. Length, can't even see that. Length times width. Length times width. Oops. Moving on from here, I would have them try a challenge problem. Now, a challenge problem, I usually give them about 10 minutes to try it, 5 to 10 minutes. I'll give them 5 minutes individual, 10 minutes in a small group. This one we'll try together. So we say Barbara's top floor is 5 feet by 12 feet. Her brother Michael wants to put a new bed in the room that has an area of 36 feet. How will this new bed fit? What is the area of the green shaded figure? Now here, this is where we start furthering that knowledge. Now we're looking at the area of the green shaded figure, separate from the areas that we find by doing this and the quotient that we find doing this one. So what that basically means is now we have to look at our length, our width and our length. We know from up here that the length times the width will be our area. So now we are saying if length times width equals the area of a rectangle, rectangle and square, I'll add, then I always have them answer in an if-then statement because it helps me see if they are applying their knowledge. Then 12 times 5 will give us the area. Now they're allowed to show their work. So 12 times 5. Some of my students will do it out. They'll be like, okay, 0, 1, and 6. Or they just write 60. Like they just automatically know it from fact fluency, and so they'll just write 60. From here, we then find the quotient because we are looking at 36 feet squared. What that means, what they already know from their prior knowledge, is that if something is squared, then two numbers were multiplied together to equal that. So if this is 36 square feet, then we can do the square root of 36, which we also know if they need to have a number here and a number here for length times width, they know that 6 times 6 equals 36. From here, this is where some of them will stop, and they'll say, okay, well, this new bed will fit because 36 is less than 60. So yes, the bed will fit. Some of my above grade level students will then further themselves into the area of the green shaded figure, which means they are now looking at subtracting cutting out 36 from 60. So they're subtracting 36 from 60 to get our answer. When we subtract 36 from 60, of course, we need to regroup. This turns into 5. This turns into 10. We have 4 and 2. So we know that the area of the shaded figure is 24 square feet, or feet squared. That is basically how I would run through the beginning of this lesson. From here, we would further into how to find the area of a triangle. What fits into a triangle, what fits into a house, things of that nature. So thank you so much for taking the time to learn about the beginning of a lesson on area, finding and decomposing different polygons to find the area of some shapes, some irregular shapes. That irregular shape was, of course, that green shaded figure around that small square, and understanding that you're furthering your knowledge of length times width using the area model or using some different prior knowledge on geometry. I hope that helps. All right, have a good one.